our last section in Unit 4 is introducing these two types of variation. One is direct and one is inverse variation. And we're going to just work through both of them. We will learn how to come up with the equation that uses direct or inverse variation, and then get information from those equations. So let's just start with the different ways that you can say that two variables are directly related. So if we mean to say that y varies directly as x, that means that I can write that equation as this linear equation, y equals kx. There are a number of ways this can be presented in a statement. One is y varies directly as x. That tells you y equals kx. One is saying y is directly proportional to x, y equals kx. And then obviously if they give you the equation. But in this, you'll notice that x and y are related to each other. K is referred to as the constant of proportionality. So here are various ways that we could see that direct variation. Here are just some examples where K is just your constant of proportionality. So folks, what that means is those two variables are related, meaning as one increases, so does the other. As one decreases, so does the other. So here's another slide that shares with you just the various ways that we can say that y equals kx. K, again, is our constant of proportionality. As one increases, the other increases. So, and to the right, you'll see these graphical representations where we can see that as one increases, the other increases as well. We're saying these things would vary directly with cost. The more gas I buy, the more it costs. The more pounds of apples we purchase, the greater the cost. As the one increases, so does the other. So let's do some examples, and we're going to be using Delta, no we're not, we're going to be using Desmos to help us with a lot of our application. So first question, we're given that y is directly proportional to x. Immediately we know that information. Then they're asking us to find k, that constant of proportionality, if we know y and x. So we substitute, and we would get 14.7 equals k times 3, and we want to solve for k, so we divide both sides. And we see that 14.7 over 3 is 4.9. So now, knowing that information, it's asking us in part B to write that variation equation. What would that equation look like? So we would plug in 4.9 for k. And there's our equation that tells us how y and x vary. Lastly, it asks us to then use that value to find y if we know that x is 9. So now we just plug in. And we plug in 9 for x. And we see that 4.9 times 9 is 44.1. So our y value is 44.1. So question 2 looks a little different. If y varies directly with x, and then we're given that y is 4 when x is 2, they're asking us to find y when we know x is -6. That seems like a lot of information. So let's break it down. First, let's start with the fact that we know that when x is 2, y is -4. We also know y varies directly as x. So we immediately use that equation. And then we plug in the values that we do know. We know that when y is -4, x is 2. So we have -4 equals k times 2. And now we're going to solve for k. So we divide both sides by 2. And we get that our constant of proportionality, k, is -2. So now we can write that equation knowing that k is -2. And so our equation now reads y equals -2x. So now we get to the second part. Find y when x is -6. So now in our equation, we plug in -6 for x, and we get that y is 12. So let's look at this word problem. We'll have a couple of these. So we know Julio's wages vary directly as the number of hours that he works. So we know wages varies directly as number of hours. So instead of us using x and y, I'm going to use W for wages, H is my hours. So here they then tell us if his wages for 5 hours, well, that's just another way of saying when my H is 5, his wages are $29.75. $29.75 is my W. We want to first find the constant of proportionality. So I'm going to plug in that H and that W that I know to find K. And I get this. And now I want to solve for K, so I divide both sides by 5. And we see that K is 5.95. I used my calculator. So then that's my constant of proportionality. So if I needed to, I know that my equation looks like this. So now I'm going to use that K to figure out how much money would he make if he worked 30.5 hours. So I want to find W, the wages, if I know H is 30.5. So in that equation that we just found, we're going to plug in 30.5 for H. And when I plug that into my calculator, I got this. So if I'm being realistic and idealistic, I would round that up. Now this brings us to our second variation, and that is inverse. So if we think about what the inverse, the opposite of multiplication is, because that's what direct variation was, then if I'm thinking, what does varying inversely mean? Well, it's going to be division, the inverse of multiplication. So let's see what that looks like in phrasing. So inverse variation can be written as follows. Y varies inversely as x, would tell us that we're treating it as y equals k over x, or y is inversely proportional to x. Same thing. K is still our constant of proportionality. So this is now saying the opposite. This is explaining to us as one increases in value, the other decreases in value. So as one, for example, the x gets really big, the y gets really small. So if I thought about speed being r equaling distance over time, as my speed increases, my time decreases. So if I looked at example 5, they're telling me that y is inversely proportional to x. Immediately I write that down. Then they're asking me to find k when I know x and y. So I plug those in and I get 13 equals k divided by 18. Now I want to get k by itself, so I'm going to multiply both sides by 18. And I get that k is 234. Then if they're asking me in B to write the equation, I now replace k with what that equals, 234. And now I can solve for any x and y. So now I'm going to find y if I know that x is 28. So I plug in 28 for x, plug that into Desmos, and I round. So if we're looking at question 6, it's the same idea, except we need to do more work to find the information. So if they're telling me f varies inversely with g, I know that has to be true. Then they give me the two values that I know. When f is 21, g is 5. So I plug 21 and 5 in for f and g. And now I have to find k. So I want to get x by itself, so I'm going to multiply both sides by 5. And that gives me that k is 105. So I can now write my equation. And so I can write my equation just like that. And now I can plug these in. What is f when g is 7? And we plug that in, and we get that f is 15. The last thing I wanted to mention is when we're working with direct or inverse variation, sometimes they spice things up with these equations. For example, if it's given that y varies directly as the cube of x, we're still using that y equals kx equation, but since it specified the cube of x, we would write that equation as y equals kx cubed. If below, you'll notice that it says y varies inversely as the square root of x. Well, it's the same idea. I know inverse variation as k over x, but in this situation, instead of writing it as x, we write it as the square root of x.